All right, ladies and gents, today we're going to get the incenter of a triangle. As we see, we have the coordinates 2, 8, 12, 5, 10, 14. So we're going to use the incenter formula where we're doing ax1 plus bx2 plus cx3 over the perimeter. So I'm going to erase that for now. So first thing we need to do is get the 3 lengths. So get ready to use Pythagorean theorem. So you could use distance formula as well, but I simply like to just encase this triangle inside of a rectangle. And hey, I'm going from 8 to 5, so this is down 3. 2 to 12 is over 10. For this length, I am going from 8 to 14, so I know I'm going up 4. 2 to 12, I'm going over, 8 to 14 is actually going up 6. 2 to 10 is going over 8. 10, 14, 12, 5. 10 to 12 is over 2. 14 to 5 is down 9. So once I do that, I know a squared plus b squared equals c squared for this length. So let me see. 3 squared is 9. 10 squared is 100. That's 109. So this length over here is going to be the square root of 109, and I already know because it's in my head already, I know that's about 10.44. I like to take these to at least 3 decimal digits because when we put these in this equation, if you only do it to 1 decimal, you're introducing a lot of error. So take this to as many decimals as you can. 6, 8, we all know 36, 64 is 100. Square root of 100 is 10, so everyone's already familiar with the 6, 8, 10 triangle. 2 and 9, 2 squared is 4, 9 squared is 81. So I know that this is the square root of 85, which comes out to about 9.219 something, but it rounds off to 922. So now, this formula tells me each one of these sides, right? Side A is going to get multiplied by the x value. This side is going to be multiplied by this x value. 10, 4, 4 is going to be multiplied by 10. So what you want to remember, if this is side A, B, and C, A is getting multiplied by the coordinates of that point. You've got a point here and here. They're both touching A. You're not multiplying this side by any one of these points. You're multiplying it by the opposite point. So I don't even really use this formula, like look at it and see what point is what. I simply look at 10, 9, and 10, and I'm going to say, hey, this side gets multiplied by that point. So in this case, it's going to be 10 times 12. Then we're going to have 1044. This side gets multiplied by the x value up here, 1044 times 10. And then this side gets multiplied by that point, 922 times 2. 9.22 times 2. Simple algebra, 10, and divided by the perimeter, 1044, and 922. So I look at this, what's that, 120? Multiplied by 10, that's an easy one, 104.4. And double 9, I get 18. Double 0.22, I get 44. And divide all that, let's see. 10 is 20, 29, 44, 22, 66. This is 29, 66. So 120 plus 114, what's that? 224 plus I've got 18, 24, 18 is 42. The decimals, 0.40, so that's 84. So we are looking at 142 I believe it was 84 over, I believe this was 129.66, and this is going to be the x value of your incenter. I believe that came out to be 8.18, right? If I recall correctly. Now, to get the y value of the incenter, I'm doing the same thing. Only difference is, instead of multiplying by the x values, 2, 10, and 12, I'm multiplying by the y values, 8, 5, and 14. So 10 gets multiplied by 5. 1044 gets multiplied by 14. 9.22 gets multiplied by 8. And the perimeter is the same numbers. A, B, and C does not change. So the y value of your incenter is going to be a y1 plus b y2 plus c y3 over a plus b plus c. So the only thing changing between the x coordinate and the y coordinate of your incenters is x1, x2, y3. X3 changes to y1, y2, y3. So now 10 times 5 is 50. I've got 1044 times 14 and 9.22 times 8. All of that is going to be divided by 129.66. And I had written it down somewhere here because so this is going to be, oh, I didn't write it down. 50, okay, all of this adds up to 269.92 over 29.66, and that ends up being 9.10. Anyway, hope this was helpful. Any questions? Are we good? So the next problems, you could always do this with, as long as you have the 3 coordinates of your point, you're going to use either distance formula or Pythagorean theorem 3 times to get the lengths of the 3 sides. Once you have the lengths of those 3 sides, you're going to be plugging those into the formula, and poof, you're going to end up with the x and y value of your incenter. Hope that helps.